Now solve 2x minus 1 modulus is greater than 3 modulus x plus 2. Now in this problem, we have seen that there are modulus on both sides and there is inequality sign. So we will solve it with the completing square method for this solution. And finally, we will check the solution with the perfection that where it is correct according to the values we got. So 2x minus 1 modulus is greater than 3 into x plus 2 modulus. So this will become 2x minus 1 whole square and then square root is greater than 3 into x plus 2 whole square and then square root by using this modulus function there. Now taking square on both sides, this 2x minus 1 whole square is greater than 3 square is 9 into x plus 2 whole square. This will become 4x square minus 4x plus 1 is greater than 9 into x square plus 4x plus 4. This will become 4x square minus 4x plus 1 is greater than 9x square plus 36x plus 36. Now we shift the left hand side towards the right hand side. So 0 is greater than 9x square minus 4x square is 5x square plus 36x minus 4x, that is plus, so it should be equal to 40x. 36 minus 1 is 35. If we take 5 common there, it should be equal to x square plus 8x plus 7 should be less than 0, or x square plus 8x plus 7 is less than 0. Now you have to find out the critical solution. This will become x square plus 8x plus 7 equal to 0. Now we will make the factors of this. It should be equal to x square plus 4x plus 3x, sorry, x square plus 7x plus x plus 7 is equal to 0, or x plus 7 plus 1 is common, x plus 7 equal to 0, or x plus 7, x plus 1 equal to 0. So if this is equal to 0, the next value will equal to minus 7. And if this is equal to 0, the next value will equal to minus 1. So on this Venn diagram, on this shaded part, it is minus 1, it is minus 7. The coefficient of x square is 1, so it is positive, so it should be a shape like this. Now they are asking that it should be less than 0. That means what? Below 0 there. So x value will be greater than minus 7, less than minus 1 is the final, not the final answer, but this is the answer from this inequality there. But we have to verify that answer with the help of this equation there, that from x from minus 7 to minus 1, let's say we put any value in between these two, from minus 7 to minus 1, let's say that is minus 4. So it should be equal to, if we put x is equal to minus 4, then 2 into minus 4 minus 1 modulus is greater than 3 into minus 4 plus 2. This will become minus 8 minus 1 minus 9. Modulus is greater than 3 into minus 2. This will become 9 is greater than 3 into 2, that is 6. So 9 is greater than 6. So this means that this value is correct there. Now, if we have to check with the graphical method, we know that 2x1 minus 1 modulus that means half of that, and this is the graph of this. This is 2x minus 1 modulus. And the second one is y is equal to 3 into x plus 2. So there are 2 points. One is this minus 7 and one is this minus 1. So in between minus 7 and 1, this graph upper is always more than this graph which is downward to that. So that means our required answer is x should be greater than minus 7, less than minus 1 is the answer of this solution to that problem there. So shaded part is the region where 2x minus 1 modulus is more than 3 modulus x plus 2 there. Again, there is modulus on both sides with a constant number. So we have to solve it. So 2 into x minus 1 square and then square root is greater than 3 into x square and then square root. Taking square on both sides, this will become 4. X minus 1 square is greater than 9x square. So it should be equal to 4x square minus 2x plus 1 is greater than 9x square. Now shifting it on one side, 5x square minus 8x will become plus 8x plus 4 will become minus 4 is less than 0 there. Now we are going to make the factors of this with the help of this critical solution, that 5x square plus 8x minus 4 equal to 0. So 5x square plus 10x minus 2x minus 4 equal to 0. 5x is common, then it should be x plus 2 minus 2 is common, then it should be x plus 2 equal to 0. Or x plus 2 into 5x minus 2 equal to 0. If this is equal to 0, then x value will be equal to minus 2. If this is equal to 0, then x value will be equal to 2 over 5. We want to draw the graph of this. It should be minus 2. It should be 2 over 5. Since the coefficient of x square is positive, so shape will be minima. Since it is less than 0 is there, so this is the required region. So x should be greater than minus 2 and less than 2 by 5. This is the answer for this simple equation there. Now we have to verify that with the modulus function whether it is which point is true and which point is not true there. So first of all, we will check in between minus 2 and 2 by 5. The best point is, let's say, if x is equal to 0, we put on this left hand side and then on the right hand side, then we are going to verify it. It should be 2 modulus 0 minus 2, sorry, 0 minus 1 is greater than 3 into 0 modulus. So this will become 1, 2 into 2 is greater than 0. So which is true there. So it means this portion is true there. Now we will check less than minus 2. Less than minus 2, let's say it is equal to minus 3. If we put minus 3 in it, then this will become 2 into minus 3 minus 1 is more than 3 modulus minus 3. this will become 2 into minus 4 modulus is 4 is greater than 3, 3s are 9. So 8 is greater than 9, which is not true. Again, we can check after this 2 by 5. Now let x is equal to 1, then 2 into 1 minus 1 modulus is greater than 3 into 1 modulus. So 2 into 0 is greater than 3. So 0 is greater than 3, which is again not true. So our solution set for this whole problem is x lying between minus 2 and less than 2 by 5. And if we have to verify it with the graphical method, the same solution, then we can have it, let y equal to twice of x minus 1. So the graph of this portion will be this 1, and this is the modulus of this. And then y is equal to 3x modulus. Then the graph of this portion will be like this. Now we have to combine these two results together. So we have seen it there that this graph, so we have seen that this graph is more than this value. So it is in between 2 by 5 and this value is minus 2. So we have seen it that the upper graph of this twice of x minus 1 modulus is more than 3 times of x modulus there. So this is the answer to verify with the graphical method, and this is the answer with the calculus method for these questions there.